welcome to my YouTube channel, Misc Corner. I am Mukul Sarma, teacher. Today I shall discuss about some miscellaneous exercise in a chapter number 5. Last class also I have discussed some problem. Today this first problem is if x minus iy is equal to a minus ibc minus id root over, prove that x square plus y square whole square is equal to a square plus b square c square plus d square. Solution. That is, we are given x minus iy is equal to a minus ib c minus ib root over. Okay, take is the number 1. Therefore, x plus iy is equal to a plus ib c plus id. Here taking, there is number 2, taking conjugate both sides, because we know that if a plus ib is equal to x plus iy, then a minus ib equal to x minus iy. Taking conjugate both sides. Now multiplying 1 and 2. Multiplying 1 and 2. Here x minus iy, x plus iy, this is root over a minus ib c minus id, a plus ib c plus ib. This is x square minus y square, a plus b, a minus b formula, a square minus b square. Here also a plus ib, a minus ib, a plus ib, a square minus ib, c square minus id also. X square, that is plus y square, because here is I square is equal to minus 1, therefore it is plus y square. Here also a square, here I square is there, therefore it is plus b square, c square plus d square root over. This implies x square plus y square whole square, squaring both sides, b square, squaring both sides. This is the problem. Next problem, which I discuss, that is expression polar form. That is polar form. Solution number has 2 problems are given. Solution number 1. Here it is 1 plus 7i. Let z is equal to 1 plus 7i 2 minus I. It is not in a plus ib form. Therefore, we have to make it a plus ib form. For this, at first we split this term. 2 minus I whole square, which is a minus b whole square formula. Therefore, 2 square, 2 into I, twice ab plus b square. That is 1 plus 7i, that is 4. 4i, this is I square is minus 1. Therefore, we can write 1 plus 7i, 4 minus 1, that is 3 minus Therefore 3 minus 4i, we have to remove imaginary, we have to remove I from denominator. For this, to take 3 minus 4i conjugate of 3 plus 4i to multiply it. 1 plus 7i. Here also 3 plus 4i we have to multiply. Now what is this? This is 3 square minus 4i square, a square minus b square formula. Here is 1 into 3, that is 3. 1 into 3, 3. 1 into 4, 4i. 21i. 28i square. That is 3 plus 25i. This is minus 28. Since there is I square, so it is I square is equal to minus 1. Therefore, it is minus 28. That is 9, 0 plus 16. Since there is I square, this we can write minus 25. 25. 20. If we take common 25, minus 1 plus I, that is, we can cancel this, minus 1 plus I. And this is A plus IB form. Therefore, we can write this as modulus of Z. Therefore, we can write this. Therefore, modulus of Z. What is the modulus of Z? This is the, here is real part. Real part is 1 square. Imaginary part is also 1. That is 1 square. That is, the part is 1 plus 1. That is root over 2. And this can be taken as R. You can write is in the polar form. It is therefore R is equal to root 2. We can take as modulus of Z R. Now what is the ARGZ? Again, ARGZ, we can take it as theta. This is minus I plus 1. Here A is negative, real part is negative, and imaginary part is positive. Therefore, it is in the second quadrant, and in the second quadrant, ARGZ is equal to pi minus 10 inverse B by A modulus. Pi minus 10 inverse. B means here is 1. We can take this is 1. Minus 1 plus I1. Therefore 1 by 1 minus 1. This is pi minus 10 inverse 1. I minus 10 inverse 10, that is pi by 4, because 10 pi by 4 is equal to 1. Now we can cancel this. Number pi minus pi by 4, that is 4, that is 3 pi. Now what is the polar form? Now polar form. Polar form of the complex number Z is equal to, we can write it as R, that is cos theta, plus I sin theta. What R is, that is root 2. Root 2. Cos theta is 3 pi by 4 plus I sin 3 pi by 4. This is the problem number 1. Now solution of problem number 2, that is 1 plus 3i, 1 minus 2i. Solution 2. Let z is equal to 1 plus 3i 1 minus 2i. Here also we have to rationalize it, or we have to remove I from denominator. So for this 1 minus 2i, we have to conjugate of 1 minus 2i, the 1 plus 2i. 1 plus 3i, this is also 1 plus 2i. Take z is equal to 1 plus 3i, that is 1 minus 2i. 1 minus 2i, 1 plus 2i, we have to write is to remove I from imaginary part from denominator. So 1 minus 2i, 1 plus 2i. And this is also to be written in numerator also. Here 1 square minus 2i square. 1 plus 2i, 3i, 6i square, that is 1 plus 5i, this is minus 6 because I square is equal to minus 1, since I square is equal to minus 1. Here is a 1 plus 2 to 4 because I square is equal to minus 1. Therefore, minus 5 plus 5i divided by, can take common, minus 1 plus I, this can see, this is minus 1 plus I. It is a plus ib form, therefore a is equal to minus 1, b is equal to 1 here, minus 1 plus I, we can take minus 1 plus I1. Therefore modulus of z, is equal to a square plus b square root over, as a means minus 1 square, is minus 1 square, that is 2. Now what is the ARG rate? We can take, therefore R is equal to root 2. We can take, now we find out ARGZ. This can be taken as theta. A is negative, B is positive, therefore it is in the second quadrant. Therefore in the second quadrant, pi minus tan inverse B by A. Therefore pi minus tan inverse 1 by minus 1. Tan inverse 1 by minus tan inverse, that is 10 pi by 4. Pi minus pi by 4, that is 4, that's 3 pi. Therefore in polar form of z, therefore polar form of z, R cos theta plus I sin theta, therefore R is here root 2 cos 3 pi by 4 I sin 3 pi by 4. This is about the problem. So next class also I shall come with some more problem.